Hello students, I am Chemistry Guru Vishnu. Today I am going to discuss a very important topic of chemistry, and the topic is hybridization. As we know, molecular species have different geometries and we can easily predict the geometry by using the concept of hybridization. This is modernmost tool for any chemist to decide geometry and shape of molecular species. Students, there are four methods which can be used to determine hybridization. So first method is calculation method, and here some numbers are written 2, 3, 4, 5, 6, 7. You can call them index or coordination numbers. With the help of these numbers, we can easily predict type of hybridization. If index number is 5, it means 5 orbitals are going to be involved in the process of hybridization, and this is why we have the only type sp3 s1 p3 d1 to 1 plus 3 plus 1 equal to 5. 1 plus 3 plus 1. Here 1 plus 3 4. Here 1 plus 3 plus 2 equal to 6. First method is here. HS hybridized state. HS means hybridized state. It is equal to index. It is equal to index. Now SA, number of surrounded atom, means hybridized state is related with a particular atom. Firstly, decide which atom you have to focus on, and you have to determine number of surrounded atoms. V, number of valence electrons, and C is charge. So this method is C is charge. This is first method. Second method, it is also calculation method, and I term it calculation method number 2. So here HS is the same as hybridized state, and V, number of valence electrons, MA, number of monovalent atoms. It means if there are bivalent or trivalent atom, then we have to leave them. And C, cation representing cation, and A, anion. You can use any of these two methods to determine hybridized state. Although in my opinion, it is dangerous to use these two methods because of some problem, and the methods are not perfect. Now the third method, total valence electron method, in my opinion, this method is much better than these two methods. So I am not going to discuss these two methods, although I am giving here the complete detail. So valence electron method is very good. So move on valence electron method. So total valence electron method. तो पहला जो स्टेप, the first step of this particular method is that total valence electrons including charge. So calculate this, just give it a symbol, total valence electrons, TVE. and these numbers will be 2, 3, 4, 5, 6, 7 and so on. Second, divide this number by 8 if value is greater than 8. Divide this number by 2 if value is less than 2. It is a short trick to determine type of hybridization. So suppose we are taking example of BF2. Example number 1. I am using two methods, third and fourth. Total valence electron method and bond formula method. So BF2, total valence electrons, beryllium has 2 valence electrons, fluorine 7 valence electron, so 2 into 7, 16. The number is greater than 8, so divide this number by 8. And this quotient is related with hybridized state. So on the basis of this 2, hybridization is SP. Now my method, bond formula method. Bond formula method means calculate number of, and this will equal to index, number of sigma bonds plus number of lone pairs. This is the best method. This is method which you can use to determine geometry of any molecular species. It's very simple, and the most important thing is, the most trusted method is bond formula method. So number of sigma bonds and number of lone pairs. So suppose this is BF2, this is bond formula, number of sigma bonds here, sigma, 2 sigma bonds, and there is no lone pair, so total is 2. 2 means SP hybridization. So what will be the geometry? Geometry will be linear. B, F, F, linear geometry. SP means linear geometry. Bond angle 180 degree. Bond angle 180 degree. Okay. So there are two methods, third and fourth. Students, 4 methods. I am giving here 4 methods. The first 2 methods have so many problems. This is why I am presenting here only last 2 methods, method number 3 and method number 4. This is method number 3, this is method number 4. I am taking another example. Another example is sulfate ion. So total valence electrons including charge, sulfur 6 valence electrons in valence shell, sulfur 16, 2, 8, 6 valence electrons, oxygen also in group 16, so 4 into 6, minus 2 means 2 additional electron, means plus 2, 32. The index is, to total valence electron is 32. Now divide this 32 by 8. 8 4 ja 32. 4. 4 means sp3 hybridization. Now my method. Firstly draw bond formula. This is bond formula. Now move on central atom. This is central atom. Here also I am calculating from entire formula, but here only related with central atom. So this is central atom. Central atom has sigma, sigma, sigma and sigma. Double bond means 1 sigma and 1 pi, and we need not to count pi bonds. We have to count only sigma bonds. So this sulfur has total 1, 2, 3 and 4. 4 sigma bonds and no lone pair, 0 lone pair. So the total of this 4 and 0 equal to 4. So hybridization is sp3. The method is very good. Third method is very good. But if we want to show the complete geometry, the total geometrical shape of a molecular species, the method is not of use. The method is of no use. The method is failed after deciding the hybridized state. What about hybridized state? Suppose we know the hybridized state is 4. So now hybridization is sp3 and we have geometry tetrahedral. So by using fourth method, which I am saying my method, you can completely give picture. This is tetrahedral bond and bond angle is 109 degree 28 minutes. Now I am taking next example here. Example number 3, water. So method number 3, total valence electrons. Hydrogen 1, 2 into 1, oxygen 6, no charge, total 8 electrons. So divide this 8 by 2. 4 means sp3. This is sp3 hybridization. Now my method. Central atom. Oxygen has 2 sigma bonds plus 2 lone pair, total 4 hybridization sp3. By using this method, total valence electron method, by using this method we can only predict hybridized shape, hybridization only, type of hybridization. But using bond formula method, we can discuss the entire geometry, the total geometry, final geometry. So if we, this is tetrahedral, oxygen, hydrogen, hydrogen, and these are 2 lone pair. Now we have to discard the lone pair, and now we have this. So it is bent or V-shaped. So if there is any question related with water molecule, then the final answer will be bent or V-shaped, which cannot be predicted by method number 1, method number 2 and method number 3 in this particular video. But it can be predicted only by method number 4. This is why I always prefer to use method number 4. This is the best method and you can easily check it. So I am presenting here next example. Next example, I'm taking just have this formula. Example number 4 here. Next example. Now we have ClF3. Total valence electrons. Cl7, F7, 28. 28 divided by 8. 4 remainder. So again divide this remainder by 2. 2 2 is 4. Now add these two quotients. 3 plus 2 equal to 5. So sp3d hybridization. Now using my method. Firstly draw complete structure. 1 2 3 4 5 6. 1 2 3 3 sigma, 2 lone pair, total 5, so sp3. In this method, we predicted hybridization sp3d, which is correct, sp3d, but what after this hybridization? It cannot be predicted by this method, but this method is capable. So if we draw this structure, and here is use of Vesper theory as well. So this is, I will make a video in which I will decide the geometry up to last line like this, and this shape is T-shaped. So we can predict full and final shape by using this method, my method, bond formula method, but other methods are totally failed to finalize this particular shape. So that's today for today's video. We will meet in my next video very soon. Till then, Jai Hind.